what is a thermal camera or thermal imager, how does it work, and would it be useful in a safety sensitive environment such as Hawkeye or automatic driving. A thermal imager works slightly differently to a regular camera. It is still an array of pixels, but those pixels are sensitive to infrared light. And they're sensitive in such a way that the hotter the object is, the response from that pixel is higher. So when you view an image in a thermal imager, you see bright areas, for example, a person's face, versus a dark background. And it's very obvious, if you see this in real time, that there is the outline of a person, and the highlighting of the skin, which is hotter, and areas of the face which is hotter versus cooler, and the background. So it's very, very useful for picking up, I guess, warm-blooded creatures like humans in a cooler environment. And it's quite sensitive to detecting small amounts of temperature change, such as the tip of your nose being cooler than your cheeks and things like that. We actually spent some time testing cameras from Fleur Teledyne, and they worked really, really well. They were small and would have been fairly inexpensive and could have been added to a Hawkeye product. In fact, we did the work to integrate and test these. Very successful in detecting people, whether it's people approaching the Hawkeye system like a bicycle rider or a pedestrian, or even a normal internal combustion engine car or truck in a night environment. However, there's a couple of significant limitations that we uncovered. We don't necessarily rule it out for a future product integration, but it could be some work that's needed. Firstly, not everything that's on the road that could be a hazard is running at a high temperature. If a car has been sitting in that environment for a long period of time, its temperature will be similar to ambient, and it's then very, very hard to actually see those temperature changes. They're almost too subtle for them to be picked up. Over time, the car heats up, especially as the engine gets hot, and you can see it the thermal waves coming down and bouncing off the road and coming through the front grille. Things like that are very, very clear as the car warms up. And then what about electric cars and other cars that don't have a front engine running really hot to make them clear and visible? So that was one of the concerns we had. The other thing is that it's a completely different world to the vision system, and AI models need to be developed specifically for this thermal world. It's almost a research and then advanced development kind of program needed ahead of commercialization. So that was quite a large body of work. I think that would be solvable, but certainly it's something we couldn't take on in a small company like us. And then the third thing was the quite low resolution. So we're using 12 megapixel cameras for our AI vision system, which means we can do things like zoom in to very great distances, up to 220 meters. We normally say 150 is where you're really detecting, but that's a long way out. A thermal imager has 320 by 280 pixels, so you can't resolve details very, very far out. In fact, it's really only out to a few meters where you could actually detect what's coming up, and that may not be enough to alert the rider to what's coming up. So I think this technology is great. I think there is a future for it. We couldn't integrate it in today. Maybe tomorrow's thermal images will be better suited. And I think we have to sort of wait and see where this technology goes.